Hello again. This is a continuation of our vector database presentation, where I was talking about how I developed a chat application, right? And what are the internals of it? This is part of demo. So we will see the flow chart diagram in a more simplified manner here. So when the user, so this is a chat application, right? The user enters some query, and that query is now put for embedding generation. The embedding is generated using an OpenAI model, like what I explained here, this one. And now, so embeddings will have a multidimensional vector, that is the result. And that is actually used for our vector similarity search. So before that, the data, what is already like for example a PDF that is scrapped, or some data that you have connected to web scrapping, or some any other data, some documentation that is stored in terms of uh, uh, embeddings again. And so now how will we query on top of it, and what does this embedding looks like, yeah, let's see this first. So this is a example of a Couchbase database GUI application. So this is a provided on cloud. You can also deploy one uh, Couchbase server using Docker. Uh, uh, this way, you will install a Couchbase application on your own machine. Just run this command, uh, and then we will have an application like this. Uh, so I am explaining this because I'm using that internally in my application, but more or less it is the same. Uh, let's go back to our cloud application. So here I have imported a color vector sample, which is a simulation of a vector database is record, where RGB is stored in the form of vectors like embeddings. And I have imported this from here. You can import this if you are starting new. And then you will be able to see the records here. If I go to documents, I'll be able to visualize this better. Uh, so this document is on the same sample, color vector here. And the color name is black. And the vector that is created is this. Similarly, suppose we have a description is a long text that if I want to create a vector out of it with a high dimensional space, this is how it looks like. So this is embedding. So that's what I was talking. What is embedding and how it looks like. Uh, so embeddings are generally created beforehand. If you have record already saved, or the text query which you just posted. So text query will be converted into embeddings on the fly. And so also one example of another vector. So this represents Navy. Navy is 00128, right? And another is dark blue. Dark blue is 00139. You can see it here. Yeah, so that's how we save the vector information in a database. And so now the data already is saved, and now on top of it I want to run a query. So I had a query that is converted into embeddings, and that embeddings I will put in a vector database where I will so here it will come here. So vector index is already created, where with that index I am querying in my database for that embeddings. And then I got k similar embeddings. What does it mean? And that is let's see what does it mean. So I have these database records, and then I will go to search, where I will go and create a search index. That's what I am talking about here. So create a vector index. So index is created. So I select that bucket where the data is stored. The collection name is RGB. And I want to go to the schema where I want to index color vector, where this is represented in three-dimensional. And I'm using by default can also use select, cosine, or others based on the versions, and then just you create an index, give a name. So I have already created an index similar to this, so I will just go there. It is shown here, color vector. This one I'll just show you how it looks like. The same, I'm using color vec, which is vector dimension, vector three-dimensional based on similarity to optimize for recall. I use this for our search. I go here and I have a query. So now go back to our model. So we have created an index. I want to do a search case similar embeddings for this query. So what is the query? The query is this. I want to search for Navy, yeah, and I want to find three similar results that looks like Navy. And then I want to search on this field. So if I search, I should get three results, and these are based on rankings. So first one will, because the Navy exists in the records, so I'll get first one as Navy itself. But if I go to second, it should be something similar to Navy. So that is dark blue. And third one is midnight blue. Wow. And if I go for more, and what did I do? What did I do? Let's go back and see. Yep. So if I search for 5 similar records, I should get fifth one. That is also similar to Navy, but yeah, it's medium blue, so a little lighter. That's how I can query whole text. The query will look a bit longer. It works very well with SDK, where you don't have to type your query here. But this is exactly what happens internally when you query embedding with an embeddings in the record, and that's what you get. So K-similar embeddings records are fetched, and so you got the records, right? You got the records, and you already have the query. Based on the query, you got the records, and then you will use this relevant snippets, and you'll combine your query. So suppose you had asked, like, find me all the navy color t-shirts. So navy items are already pulled in, and it will use this context. Retrieve context is the number of records, K records that I collected from the database. And then it will be fed to LLM, large language model, for getting an enriched uh, response. So enriched input is pushed into LLM, where LLM will process your query, the question you have asked, and the context what we retrieved from a database. So LLM has a higher context now. You could have asked the same question to LLM. It could have answered it before, but the answer might be more of a generic, and may not be real time. And so with this approach is called RAG, retrieval augmented generation. So with this, you have a better context, and the exact context where the answer will be found from the LLM. And this coherent answer is pushed back to the user in the natural language. So that's all the job of the LLM model. So again, we don't have to do much of LLM. We can use a third-party LLM model like OpenAI's ones, or anything from ChatGPT, Claude, or anything. So, but the concept is that, are you able to connect the dots that this is a real-time thing, that my database, tomorrow if I have more colors, more details, I can add to my records, and I don't have to change anything in my application. I should be able to query based on the latest records. So if I am web scraping news articles, I should be able to search based on the latest articles. That's how your RAG application is built. Same thing is explained in this project. It's done here. So this is more detailed, right? So when the text is given, it is tokenized, text is processed, chunking happens. We use a specific model, 1536 dimension, The embedding model creates OpenAI created embeddings, and that we push to a vector search on the Couchbase database. This is how our vector index is created. These are some details to the index. And then it talks to the embeddings, which are already saved in our database. So how you created this embedding, this is another parallel where the PDF was uploaded or a web page was scrapped, and we created an embedding again with the same model. Yeah, that is important. Like the models to model, embeddings to embedding communication happens when the models are same or at least compatible. And then it has stored in the Couchbase database, again, the chunks in the form of vector embeddings. And then the communication happens. You retrieve the chunks based on your query, the similar records only. You push it to LLM. You get the LLM does the conversion of the response into English or any your language, and you get a response. So that's how you develop a RAG application. It's quite easy. Just to know things is you should have an OpenAI API key to run this. Yeah. So what you need is OpenAI key. It's paid. Yeah. I'm not running this demo now. And Couchbase can come free for trial version, or at least for the samples. It's all free. You can deploy through Docker if you are running it on local, or you can connect through a connection string on the cloud, like I explained in my sample. This one is a cloud-based. Yeah, so this is more of it. If you have any question, let me know. I hope I have covered my things. Thank you.